All right, scholars, let's take a look at the think about it. Callie's teacher asked her to rename the fraction 3 over 4 with eighths as the new unit. She wrote 3 over 4 equals 6 over 8. Is her equation correct? Prove it in the space below. If you finish early, look for another way. Okay, let's take a look at this visually. Like I showed in the aim, using the fractions that we have right now, which is 3 over 4 and 6 over 8. So I'm going to just draw a line right here. And first, I'm going to go ahead and represent this first fraction, which is 3 over 4. So I know I need 4 parts. So I'm going to draw a line down the middle for both, actually. And then for this one, I'm going to make it have, let me do a better job here. I'm going to make it have 4 parts. Okay. And I'm going to continue here. Let me go create the other one that's going to have 8 parts. And I want to do this right now so to show you how, if we could find out if these are equivalent fractions. So extending this line right here, and right now this one's also 4 parts, but I want it to have 8 parts. So I'm going to draw a line down the middle right here and right over here. So now I got 4 right there, but I'm going to do the same thing over here and over here. So now we have 8 parts right here. So if we were creating a fraction right now, the denominator here would be 4 because this represents the total number of parts. So that's 4. And the denominator for this fraction would be an 8 because there are 8 parts that are being described here, and there is 8. Okay, so now we're going to take care of the numerator, which is the top number in the fraction, and that's going to show how many parts of the whole are being described. All right, let's go ahead and go with purple for the 3 over 4, and I'm going to shade in 3 parts. So what I'm shading in is going to represent the numerator. And I won't spend too much time on that. Okay, so I'm going to go ahead and write this fraction right over here. So this represents 3 over 4. Okay, all right. So let's go ahead and go to the next fraction. And we want to show 6 over 8 for this one. And let's go ahead and go with yellow. And let's make sure 1, 2, 3, 4, 5, 6, 7, 8. All right, so I'm going to shade in 6 because I want this to represent 6 over 8. All right, so now I'm going to write this fraction over here, and it's going to represent 6 over 8. So we got 6 over 8. And the reason I'm doing this right now is, and maybe you figured it out, there is a different approach we can take. And the reason why is because if I multiply this by 1, it stays equivalent. So let me give a quick example. For example, if you have a 4 and you multiply the 4 by 1, it's going to stay the same. It's a 4, right? So anything you multiply by 1 is going to stay the same. So what I want to do here is I want to see, is there a number that I could multiply this 3 with to get to 6? And the number I'm thinking of right now is 2. But right now, this isn't a 1. But if I put a 2 underneath here, that's going to represent a 1 because it'll be a whole, 2 over 2. Okay, it's like if I were to shade this entire top fraction in 4 over 4 would just be 1 whole. But it's not going to work if this 4, if I multiply it by 2, if it doesn't become an 8, it won't work. But it looks like it does. It does work. 3 times 2 is 6, and 4 times 2 is 8. So that means these are equivalent fractions, okay? Let me quickly just show you. Let me make another fraction over here. Let's go with 5 over 10, just to show you that how something may not be equivalent. first off, I can't even think of anything to multiply into 5, right? So this one is pretty simple, or not simple, but it's a little bit faster to figure out that it's not equivalent. But let's say I have 6 over 10. All right, so we got to be careful. 3 times 2 equals 6. But now you got to multiply the 4 by 2. Doesn't work. All right, so that's how another way how you could figure out if fractions are equivalents.